October 15, 2025. 11:47 p.m. Greenwich Mean Time. No warning. No press conference. Just a silent alert, triggered simultaneously at every major space agency around the world. NASA, ESA, JXA, ISRO. All of them lit up at once. The data? Simple, but impossible to ignore. An object, moving at more than 155,000 miles per hour, heading straight for Mars. At first, it appeared to be just another asteroid, maybe a rogue comet. We've seen those before. But then, one line in the report changed everything. Estimated age, 8 million years. 8 million. That's older than humanity. Older than Earth as we know it. And definitely older than anything still drifting inside our solar system. Because this object wasn't from here. It came from somewhere else. Deep space. Interstellar space. And within hours, it had a name. 3IATLAS. 3I for interstellar. The third confirmed interstellar object ever discovered by humans. But this one? This wasn't just a flyby. Because 3IATLAS wasn't acting like a visitor. It was approaching like something with a destination. And before we knew it, it had crossed a line. Not a border drawn on any map, but a line that separates observation from interaction. That's when the story really began. I still remember the night it all began, July 1st, 2025. A remote observatory high in the mountains of Chile spotted something strange. Nothing dramatic at first, just a dim object gliding across the sky, barely distinguishable from the background stars. The Atlas telescope picked it up, a system designed to scan for potential Earth-impacting asteroids. But this didn't look like anything we'd seen before. Within 6 hours, 3 red flags popped up, and each one made things more serious. First, speed. This thing was moving at over 153,000 miles per hour, faster than anything the sun could gravitationally bind. That meant it wasn't from here. It wasn't orbiting. It was passing through. Second, trajectory. All the planets in our solar system orbit the sun in the same general direction, like a cosmic ballet. But this object? It was coming in the opposite way, like a fish swimming upstream. Third, and this is what really sets it apart, spectral data. When sunlight passed through the gas around it, it didn't show the usual signature. No water. No dust we'd expect from a normal comet. Its chemistry was completely off. Unfamiliar. Alien, at least in the scientific sense. That night, an alert went out to every observatory on Earth. The object was officially designated 3IATLAS, the third known interstellar object ever detected by humanity. To understand why this is such a big deal, we need to rewind a bit. In 2017, astronomers spotted Oumuamua. Long, cigar-shaped, spinning strangely. No tail. No visible outgassing. And it accelerated in a way that didn't quite fit any natural model. To this day, we still don't fully understand it. Some, including Harvard's Avi Loeb, suggested it might be alien tech. 2 years later came Borisov, a normal, interstellar comet. Water, dust, ice, tail, just like the ones from our own system. But from somewhere else. And now, 3IATLAS. It wasn't as silent as Oumuamua. But it wasn't as familiar as Borisov. It was outgassing, but with chemicals we didn't expect. Its spectral signature didn't match any comet we've ever studied. And based on some models, this thing might have formed 8 billion years ago, long before our sun was even born. Then came James Webb. On September 20th, NASA officially tasked the James Webb Space Telescope, the most advanced space observatory we've ever built, to study this object. Its mission, lock onto 3IATLAS, confirm the trajectory, and determine how close it would come to Mars. Initial models showed a safe pass, close, but not dangerous. But then, something small, almost invisible, changed everything. A tiny deviation. Just 0.0003 degrees. Insignificant on paper. But in space? That difference meant everything. It was the difference between passing by and hitting something. Simulations were rerun. Models recalculated. And for the first time since detection, a collision scenario was added to the list of possibilities. This object wasn't just a mystery anymore. It had become a concern. We'd gone from passive observation to active risk assessment. And that shift, that moment when the astronomy community realized this object could interact with one of our planets, was honestly chilling. Because up until now, these interstellar visitors had just passed through, like ghosts. Here, then gone. No contact. No consequence. But 3IATLAS? It had a direction. A speed. A history written in unfamiliar chemistry. And now, a possible impact trajectory. This wasn't just about studying something strange. This was about preparing for something real. As 3IATLAS approached Mars, I, along with thousands of scientists and observers around the world, was glued to the incoming data. Images started pouring in from every angle. From James Webb. From MAVEN orbiting the red planet. From Lucy, still trekking toward Jupiter's Trojan asteroids. And what we saw went beyond anything we expected. October 3rd, 9 a.m. 3IATLAS reached perihelion, the closest point to the Sun in its trajectory. But that wasn't the part that made everyone hold their breath. It was the distance from Mars. Just 19 million miles. Close enough for orbital spacecraft to get a look at this object like never before. The MAVEN spacecraft was the first to send back high-resolution images. Its instruments showed a strange, chaotic magnetic environment around the object. Ion particles were being expelled at abnormal speeds. Then came a surprise from Hubble, an infrared image showing a faint glow surrounding 3IATLAS's icy shell. Not white, not blue, but a soft, violet-red halo, something we'd never seen from any comet before. While we were still reviewing that data, it happened again. The second deviation. On October 8th, a subtle but critical change in outgassing, what we call sublimation thrust, caused 3IATLAS's trajectory to shift again. But this time, it wasn't a tiny correction. It was nearly 1/10 of a degree. That may sound small, but in space, at these speeds, that's enough to alter everything. NASA's alert systems went into high gear. I remember the emergency meeting clearly. It started at 3 a.m. Eastern Time. Scientists from JPL, ESA, MIT, and JAXA, all of us were running new models in real time. Then one phrase hit the network. Possible impact corridor identified. 3 scenarios emerged, and not all of them were comforting. Scenario 1, a direct impact on Mars's southern highlands. Estimated energy release? 30,000 megatons. Enough to create a crater over 30 miles wide. Scenario 2, atmospheric breakup. 3IATLAS might skim the upper atmosphere of Mars, fragmenting into thousands of pieces. Smaller impacts, yes, but still potentially measurable. Scenario 3, the best-case outcome. It flies by, leaving the Martian system entirely untouched. But the truth? We didn't know which way it would go. At over 155,000 miles per hour, even the smallest margin of error, fractions of a degree, could change the outcome entirely. So we watched. Every image. Every spectral readout. Every wobble in the gravity field. And deep down, we all knew this wasn't just something we were observing anymore. This was real. This was an event. A cosmic moment unfolding in front of us, and we had no idea how it would end. What scared me most wasn't the possibility of impact. It was that we still didn't understand what this thing really was. Was it a comet? A fragment from a dead star system? Or something entirely new? Something we didn't have a name for yet? That question became the center of the entire scientific conversation. And if 3IATLAS did strike Mars? It would give us a one-time opportunity, our only shot, to study preserved material from a completely different solar system. A sample we could never recreate. Something no probe could fetch. No mission could replicate. A true time capsule. And inside it? Maybe the first clues about how life begins. But only if something survived the impact. Only if there was something left to study. The James Webb data finally came in. And honestly, I still don't know how to describe what it felt like. Anticipation. Tension. Awe. All of it, crashing together in one breathless moment. From over 277 million miles away, the most powerful telescope humanity has ever built had locked onto a frozen object just a few kilometers wide, and gave us something no one expected. Not a close-up photo. Not a signal. But something far more important, a chemical fingerprint. Using infrared spectroscopy, Webb let us see the very molecules streaming off the icy core of 3IATLAS, the gases being released as it got closer to the sun. And hidden in that stream was the moment that turned everything on its head. The dominant gas? Carbon dioxide. Not water. Not carbon monoxide like we typically see in comets from our solar system. Just carbon dioxide. And a lot of it. The CO2 to H2O ratio was nearly 3 times higher than anything we'd measured before. To most people, that might sound like a footnote. But to planetary chemists, it was a lightning bolt. Because that one ratio told us something staggering. 3IATLAS wasn't made here. It didn't form in the same environment as any comet we've ever studied. It came from somewhere with weaker radiation. A different chemical recipe. Maybe a colder star. Maybe even a dying one. And it wasn't just CO2. Buried in the outgassing trail was something else. Nickel. Now, nickel doesn't mean life. But it does mean something. Because most comets don't have much of it. In fact, nickel is rare in these icy objects. But 3IATLAS had it in surprisingly high concentrations. That led us to one possible explanation. Maybe this thing didn't form in a calm, cold nursery. Maybe it came from somewhere more violent, near a supernova remnant, or inside a metal-rich region of an old star system. In other words, this wasn't just an old object. It was a chemical time capsule from a system that no longer exists. A messenger. A relic. A survivor. And if you zoom out for just a second, it hits you. This isn't science fiction. This isn't fantasy. It's real. Floating in space. Right in front of us. A frozen traveler carrying the raw ingredients of some long-lost world. Hours after the Webb data hit the global science networks, NASA called a press conference. I remember the moment clearly. Everyone does. Amit Kshatriya, NASA's acting administrator, stepped up first. No dramatic pauses. No speculation. Just the facts. This object is a comet. It looks like a comet. It behaves like a comet. And all available evidence confirms that it is a comet. Then came Nikki Fox, Associate Administrator for Science. There are no technosignatures. No propulsion systems. No signals. Nothing artificial. This is not an alien spacecraft. Just like that, case closed. No aliens. No cover-up. No mysterious technology. But that, ironically, made it even more extraordinary. Because what we were left with wasn't a sci-fi fantasy. It was reality. Tangible. Undeniable. This wasn't a probe. It wasn't a message. It wasn't a visitor trying to be found. It was something better. It was evidence. Proof that the chemistry of other star systems could cross the void. That matter can survive for millions, even billions, of years in deep space. That interstellar objects don't just pass through, they carry stories. Of ancient stars. Of shattered planets. Of chemical processes we've never seen before. Tom Statler, NASA's lead scientist on small bodies, said it best. It gives me goosebumps to think about. This is a new window into the makeup and histories of other solar systems. And in that moment, I realized something. 3IATLAS wasn't just a scientific discovery. It was a conversation starter. Between us and the rest of the galaxy. Not through language. Not through signals. But through chemistry. A message written in atoms and light. After NASA's press conference, the whole alien spacecraft debate started to quiet down. But for me, and honestly, for a lot of people in the scientific community, another question started burning even hotter. Could this comet carry signs of life? We didn't find engines. We didn't find signals. We didn't find tech. But what we did find was not normal. Hidden in the Webb telescope's infrared data were molecules, complicated ones. Organic compounds. Long chains of carbon-based molecules. The kind you'd expect to see in dense molecular clouds or near dying stars. Not floating between galaxies. They weren't amino acids. They weren't cells. But they were complex enough to matter. Because somehow, these molecules had stayed intact, locked inside the frozen core of 3IATLAS, for hundreds of millions of years, maybe even longer. I remember someone calling it a chemical time capsule. And that's exactly what it is. A frozen archive of ingredients from a star system that might not even exist anymore. And that's when a once fringe idea came crashing back into the conversation. An idea called panspermia. If you haven't heard of it, here's the core of it. Panspermia is the hypothesis that life, or at least the building blocks of life, can travel between planets or even between star systems. Not in spaceships, but inside rocks, inside comets, inside objects like 3IATLAS. I know. It sounds like science fiction. But after seeing this data, it doesn't feel so crazy anymore. Here's why. First, these complex molecules survived. For millions of years. Exposed to radiation, cold, and the vacuum of space. And they made it intact, protected by ice and dust deep inside the comet. Second, we now know, undeniably, that material from other star systems can reach us. 3IATLAS is the proof. It made the journey. It got here. And it carried chemistry we've never seen before. Third, some microbes, on Earth, can survive space. Tardigrades, for example. Tiny, indestructible, water bears. They survive the vacuum of space, intense radiation, and freezing temperatures. Some types of bacteria have even lasted months on the outside of the International Space Station. So what if? What if a comet like 3IATLAS didn't just carry molecules? What if it carried microbes? And what if it had landed, gently, on a young, water-covered planet like early Earth? Then what? We don't have the answer. But we can't ignore the possibility anymore. Let me be clear. 3IATLAS did not bring life. It didn't contain bacteria. It didn't seed Earth. But it did prove something we never had evidence for before. That panspermia, this radical idea that life can move between stars, isn't impossible. In fact, it's starting to look kind of likely. No, it doesn't confirm where life began. But it expands what we're allowed to imagine. Because if the raw ingredients of life can survive the journey, and reach other planets, and interact with new environments, then maybe, just maybe, life doesn't always begin from scratch. Maybe sometimes, it spreads. Now let's zoom out for a second. Picture Earth. For billion years ago. Volcanic. Violent. Constantly bombarded by comets and asteroids. What if, just what if, among those thousands of impacts, one of them was a comet like 3IATLAS, carrying organic compounds, formed in a star system long gone, landing in the early oceans of a planet we now call home? And what if that comet helped tip the scales? What if it brought one ingredient Earth was missing? One catalyst that nudged pre-life chemistry into real biology? If that happened, then we are not just Earthlings. We are hybrids. A mix of local and interstellar chemistry. We're not just made of star stuff. We're made of shared stuff, matter exchanged between solar systems. That idea? It's mind-blowing. And 3IATLAS didn't bring aliens. But it brought hope. Hope that the universe is more connected than we thought. That life might not be rare. It might be inevitable. Not because it magically appears, but because it spreads. Like spores on the wind. Like seeds between worlds. When 3IATLAS finally slipped past Mars and out into the dark, it didn't leave destruction in its wake. No explosions. No signals. No dramatic last-minute twist. But what it did leave behind, at least for me, was something far more profound. A new way of seeing the universe. Looking back at the full journey, from that first flicker of light spotted by Atlas in Chile, to the massive coordination of 20 spacecraft tracking it across the sky, what stands out isn't just the data. It's the shift in mindset. For the first time in human history, we were ready. Not scrambling to catch up. Not reacting too late. We prepared for an interstellar visitor. The James Webb Space Telescope, the Hubble, MAVEN, Lucy, and SOHO, each of them pivoted from their missions to track a rock just a few kilometers wide. That alone says something huge. We're not just watchers anymore. We're participants. Not in a conversation with aliens, but with the cosmos itself. A dialogue written in light, in molecules, in dust. And 3IATLAS was the opening line. The data it left behind, its chemical trails, its dust patterns, its spectral signatures, will take years to fully decode. And honestly, I think some of its secrets may still be decades away from being understood. But even now, this comet has already given us three enormous gifts. First, it proved, without question, that interstellar space is not empty. It's not a void. It's a river of matter, flowing between star systems. And sometimes, it carries messages, stories etched into frozen minerals and alien ices. These aren't just rocks. They're fragments of long-lost places. Artifacts of stars that died before our sun was born. Second, 3IATLAS reminded us that the cosmic timescale is almost unfathomable. This thing might have started its journey before Earth even existed. Before the sun was a sparkle in a collapsing gas cloud. And somehow, by chance or fate, it arrived in our solar system now. Right when we had the tools to notice it. To study it. To learn from it. If that's not cosmic timing, I don't know what it is. Third, this comet opened the door to an entirely new branch of science, interstellar archaeology. Up until now, if we wanted to study other star systems, all we could do was look, watch their light, measure their wobble, decode the faintest signals. But now we're starting to catch pieces of those systems in our own backyard. 3IATLAS is more than a comet. It's a sample. A tangible, touchable, testable piece of a solar system that no longer exists. And every one of these visitors that comes next, they'll be time capsules too. But maybe the most powerful thing this object gave us, it wasn't scientific at all. It was emotional. Because somewhere along the way, this lonely little comet captured the imagination of millions. People who don't normally care about space suddenly found themselves asking big questions. What else is out there? How many more are coming? Could one of them change everything? It pulled our eyes upward. It reminded us how small we are, and how vast everything else is. And that's important, because science isn't just about data. It's about curiosity. It's about the feeling you get when you realize the universe is talking to you, and for once, you're listening. Carl Sagan once said, "We are made of star stuff." And 3IATLAS made that idea feel literal. The carbon, the nickel, the oxygen inside that comet, they're the same ingredients that make up you and me. But they didn't come from Earth. They were forged in the heart of a star, ejected by a supernova, swept into clouds, recycled into planets, passed along from one place to another, until one day, some of it landed here and became us. So when 3IATLAS came through, carrying pieces from another system, it wasn't just a visit. It was a reunion. Long-lost family, returning across the stars. So what now? Well, starting next year, the Vera C. Rubin Observatory will go online. And once it does, we expect to detect dozens, maybe even hundreds of interstellar objects every year. That's not an exaggeration. We're on the edge of a new era. The era of interstellar archaeology. An age where the secrets of alien star systems aren't light years away. They're just one telescope click from being found. Some of those future visitors may be familiar. Some may be strange. And maybe, just maybe, one of them will be impossible to explain. Until then, 3IATLAS stands as the first chapter. Not the final answer, but the beginning of a bigger question. A reminder that we are no longer just looking out. We're reaching out. And the universe is reaching back. I still remember the final moment when 3IATLAS drifted beyond the inner solar system. No sound. No warning. Just gone. But we saw it. And from that moment on I knew. Everything had changed. We've entered a new era. A time where interstellar objects, visitors from distant star systems, are no longer once-in-a-century anomalies. Since 2017, we've detected 3 Oumuamua, 2I/Borisov, and now 3IATLAS. 3 visitors. In just 8 years. And that's with old technology. So what happens next? Soon, the Vera C. Rubin Observatory will go live. It's one of the most powerful sky survey instruments ever built. And once it starts scanning the heavens, we may start detecting dozens, maybe even hundreds, of interstellar objects every single year. Let me say that again. Not every century. Every year. Just imagine it. Every week, a new interstellar visitor. Some icy, some rocky, some familiar, and some completely alien. One of them might carry bizarre chemicals. Another, dust grains we'd never seen before. And someday, maybe not long from now, one might defy every natural explanation we know. Maybe not life, but something impossible to ignore. But let's not get ahead of ourselves. Even here and now, the coming decade is already packed with promise. The Europa Clipper will visit Jupiter's moon Europa, a place that may hold an underground ocean teeming with microbial life. The James Webb telescope will continue scanning exoplanet atmospheres, hunting for hints of biology. SETI will keep listening, waiting for a whisper from another civilization. And our Mars rovers will keep digging for ancient fossils in red Martian soil. 3IATLAS didn't answer the big question, but it pointed us in the right direction. It reminded us, this universe is more alive than we ever imagined. And maybe, just maybe, we're not alone. I used to think the question, "Are we alone?" was philosophical. Now, I think it's technological. It's no longer, "Is there someone out there?" It's, "When will we be advanced enough to find them?" Every telescope, every spacecraft, every object like 3IATLAS brings us closer. not just to alien life, but to a deeper understanding of who we are. What moved me most, though, was something I didn't expect. When 3IATLAS hit the internet, it wasn't just scientists who paid attention. Celebrities tweeted about it. People made memes about it. YouTube exploded with wild theories and earnest questions. I saw the same sentence pop up everywhere. What if it's a message? And I realized, every time something arrives from between the stars, it awakens something ancient in us. The part of us that stared at the stars as a child. The part that dared to wonder how big the universe really is. The part that quietly asks, is there more to this life than just molecules and physics? 3IATLAS didn't answer that, but it made us ask again. And sometimes, that's even more important. Maybe you're not an astronomer. Maybe you're not a scientist. But you're still part of this story. Right now, you can go to eyes.nasa.gov and track objects moving through our solar system. You can join real citizen science projects on zoaniverse.org, help classify telescope images, and support real research. You can download apps like Stellarium to follow the night sky and see these objects for yourself. You don't need a degree. You just need curiosity. Because sometimes, curiosity, not credentials, is what moves humanity forward. I don't know when the next interstellar visitor will arrive. It could be next year. It could be next month. Could be next week. But I do know this. We'll be ready. We have the technology. We have the people. We have artificial intelligence, big data, and a planet full of minds watching the sky. And more than anything else, we have the desire to understand who we are, and whether anyone else is out there with us. Right now, 3IATLAS is fading, disappearing into the void. But what it left behind is light. Not just photons, but curiosity, hope, a belief that the universe isn't silent. It's speaking. In dust, in light, in chemistry in motion. And our job? It is to keep listening and keep looking up. Whenever I look up at the night sky now, knowing that 3IATLAS is out there, somewhere, drifting through the darkness between the stars, I feel something deeply human. A quiet, aching wonder. We used to believe we were the center of the universe. Then Galileo came. Newton. Einstein. And layer by layer, our illusion of cosmic importance was stripped away. Now, with every interstellar object like 3IATLAS, the message is loud and clear. We are a tiny part of something vast. But strangely, that makes us feel more connected, not less. Because against all odds, in the middle of a galaxy spinning for billions of years, we exist. And not just exist, we wonder. We notice a distant comet cutting through the sky, and we ask, could this be carrying the answer to the oldest question of all? Where do we come from? Maybe not today. Maybe not even in this lifetime. But the search itself, that hunger to know, is what defines us. We're not outsiders looking into the universe. We're part of it. Every atom in our bodies was forged in the heart of a dying star. Every thought, every dream, every heartbeat, it's the cosmos, thinking about itself through us. 3IATLAS came and went. Not to threaten or to terrify, but to leave behind something quieter and far more powerful. Hope that there's still so much we don't know. That the mystery isn't over, it's just beginning. That someday, maybe, another object will come, not just with dust and ice, but with a message. Until then, I'll keep looking up. And I hope you will too. Because the universe is whispering something. And our job is to listen.